Okay, in this video we're talking about Newton's third law of motion, and basically what that states is that when one object exerts a force on a second object, the second object exerts a force on the first that is equal in strength and opposite in direction. You may have heard it also stated like this: to every action, or something similar anyway, to every action force there is an equal and opposite reaction force. And so sometimes we call this the action-reaction law, or action-reaction pairs. All that refers to Newton's third law of motion. An example of this would be if you were to push on a wall. Just like this person right here. So if you push on a wall, you're applying a force on that wall, but the wall is also applying a force back onto your hands. And so in this case, the action force might be you applying a force to the wall, and then the reaction force might be the wall applying in the opposite direction. It doesn't matter necessarily which order you put those in. So in this case, the action force could be the wall exerting a force onto you and you being the reaction force. It doesn't matter which order you put those in. Just know that there is an action and a reaction force. Another example of that would be, or a classic example of that would be a rocket, and we kind of talked about this in class a little bit and how those work. So if you had a rocket, and you can kind of picture this being the end of the rocket here, so you can kind of think of it this way. And you have the cone here. What's actually happening in a rocket that applies to Newton's third law? Well, on the inside, and how the rocket actually gets going, if we have some kind of explosion on the inside, so this gas on the inside is combusting, and it's heating up and expanding and applying pressure in all directions, right? And so this gas is actually applying a force to the top of that chamber, pushing the rocket in this direction, and then the rocket is applying a force in the opposite direction and expelling the gas out the other end. So there's a reaction force and then a reaction force in the opposite direction. So that's kind of how a rocket works. Now, one thing that you need to know about action-reaction pairs is that they occur at the same time, and the forces are always going to be equal, and that might not always be too intuitive to you, but here's an example real quick to kind of explain how that happens. So let me show you real quick. Let me go to a video here. And so in this video you have a guy on this side who is going to apply a stronger force, so he's a bigger guy, and we have two scales in the middle, and they're going to be pulling on these two scales. And so this one, again, this guy over here is going to apply a larger force, but let's see what happens with the scales here. Okay, so he's going to pull on there, and you can see the scales are exactly the same because they have an equal force. It doesn't matter that he's applying a greater force. Whenever they're pulling on each other, they're going to apply basically the same force in opposite directions. So hopefully this was helpful with Newton's third law, and I'll see you guys in class. You guys just need to do the summary of the video, and that's it. There's no practice problems that go along with it. See you in class next time.